So I have written my chemistry textbooks with one goal in mind, and that is that I wanted to write a text that students would actually use. And in order to accomplish that, I tried to rely on two basic principles, and those are write the text in a student-friendly fashion and use relevant and interesting examples so that students would actually enjoy what they were reading. So first of all, how is my text student-friendly? Well, for me, the key was to prepare the material write it in short paragraphs and place all key material in highlighted bullets so that the material would jump out at students. I have been teaching chemistry for lots of years, but truthfully, this plan on exactly how to do this resulted mainly from student feedback that I got during the 1997-1998 academic year when I was a visiting professor here at the University of Hawaii. During that year, my goal was to take my handwritten lecture notes and type them into the computer, and to take a program called ChemDraw and take all of my structures and intersperse them in the lecture notes. And I also at that time added a bunch of examples that I had saved in binders over the years. These were relevant and interesting applications that students might enjoy reading about. And so I added those to the lecture notes as well. And when I typed my notes in, I did this in this short paragraph bulleted fashion. And then I took these notes and I placed them on reserve in the library. And partway through the semester, students started coming to me and asking me if I could take my notes and bring them to a copy shop. And I said, well, okay, we can do that. But then I started pressing them and asking them, well, why are you doing that? Why don't you have a textbook? Why can't you use your textbook? Why are these notes so valuable? And they said to me, we've stopped using the textbook. And I said, well, why is that? And they said that reading my lecture notes that were more than just lecture outlines provided them with the same amount of material in fewer words, and it was much easier for them to understand. And they said, instead of having to read a long paragraph and sort out the material that was important in that paragraph, I had done that for them already. And then they would say to me, why don't you write a textbook? And so that that was the beginning of the idea that maybe if I did write a textbook that used these shorter paragraphs and placed key concepts in bullets, that would make a text that was more student-friendly, and therefore students would use it more. The second aspect of all of this is I wanted to use relevant examples to explain phenomenon. So for example, say we were talking about the fundamental concept of solubility. Now, a chemist could talk about why a certain compound is water soluble or fat soluble, and they could take something like sodium sulfate and explain why sodium sulfate dissolves in water. But truthfully, not many people would be very interested in that. Not even a chemist would be all that interested in that. But instead, if you talked about the fundamental nature of a compound and why it might be soluble in a certain solvent like water or insoluble in a certain solvent like water, then you could use that fact, which doesn't take long to explain, and use that fact to illustrate some topics that a student might find interesting. For example, this explains why certain vitamins are fat soluble and certain vitamins are water soluble. And then it gets to explaining why you can't ingest too much of a vitamin that is fat soluble because it gets stored in the body. And that is a relevant concept that students understand. Solubility explains why water alone doesn't clean away dirt, why you need soap. It also explains many environmental phenomena. For example, why if you have an oil spill, does that oil not dissolve in water? But yet when that oil gets on a bird, it washes away the oils that are on the bird. So by using concepts like that, students find the material that they're learning more relevant. But there's another aspect in this, and that aspect is the following, and that is several books do have these, what we call application materials, but they relegate them to boxed readings, or they place them at the end, for example, of a book, or at the end of a chapter. And what often happens then is students may skip the boxed reading, or professors may not get to the material that's the relevant application material, and therefore students never benefit from it. And so what happened to me, once again, there's a story, and when my oldest daughter, Erin, was in college and taking chemistry, I started asking her, I said, Erin, do you like these boxed readings that are present in your chemistry book? And her answer was, I absolutely love them, Mom. And I said, well, why is that? And her answer was, because I know I can skip them and I will never be tested on them. And I went, oh my God, that defeats the whole purpose. So the second aspect then of having these application materials came to light in my mind, and that was, let's take this application material and not relegate it to a box. Let's put it in the chapter. Let's put it as a specific section in a chapter, or integrated into figures that are referred to in the chapter, so that students would less likely to skip it, and also ask students questions about this material, either within the chapter or at the end of the chapter, or both places. And so students understand the importance of this material and they will read it. To summarize then, my hopes and goals in writing my general organic and biological chemistry text is, I have written a book for students, not for professors. Now, I do hope the professors who teach from this book will find it easy to use and interesting to use, but I hope that the students who use the book will really learn from it. I think that chemistry is a beautiful and logical discipline, and I think it explains the world around us. I hope that by enjoying a chemistry course more, and by having a book that is easy to use, that a student will learn and therefore appreciate the world of chemistry more.